So for this function, we need to find the creative point and test if the function is at relative max or minimum. To do this question, we need to do the first order condition. We need the partial derivative for the x first and do the partial derivative for the y. So first of order condition, we do the partial derivative for the x. So for the 3 times y to the power 3 will be the 0 minus, so for the x to the power 3 is 3, minus 3. For the 147x is 147 minus 54y will be minus 0, so 12 will be the 0. Now we do the y. That y is equal to, for the 2 times y to the power 3, so it will be 6 times y to the power 2. So minus x to the power 3 will be the 0. 147x will be the 0. So 54 times y will be minus 54. 12 will be the 0. So we just rewrite the function for the zx is equal to, sorry, this is x to the power 2 plus 147. So this is minus 3x to the power 2 plus 147 equal to 0. Zy equal to 6 times y to the power 2 minus 54 equal to 0. Need to find the x and y, so I rewrite this one. Minus 3x to the power 2 plus 147 equal to 0. The 6y to the power 2 minus 54 equal to 0. For the x is equal to negative 3x to the power 2 equal to negative 147. X to the power 2 is equal to 147 divided by the 3. So x has two solutions. X 1, 2 is equal to a positive and negative square root 147 over 3. So for the y is 6 times y to the power 2 is equal to 54. Y to the power 2 is equal to 54 divided by the 6. So y has two solutions, 1, 2, equal to positive and negative square root of 54 over 6. So this is equal to positive and negative 7. This is equal to positive and negative 3. We have 4 critical points now. So 4 critical points. Point A is 7 and positive 3. For the point B, 7, negative 3. Point C is negative 7, positive 3. Point D is negative 7, negative 3. We use the second order condition to check these points. Second order condition to check that x, so check this one now, is equal to negative 6x. So this one we checked. So for the zyy, we check this one now. Is 12y. So for the zxy is equal to 0. For the y x is equal to 0. At point A, so for the z x is equal to negative 6 times 7 is equal to the negative 42. So smaller than 0, that y equal to 12 times 3 equal to 36, greater than 0. For the z x times z y smaller than z x y to the power 2, this is negative 42 times 36 is smaller than 0 because zxy equal to 0, so this is 0. So for the condition, zx times zy is smaller than 0 and zx and zy smaller than zxy to the power 2. If these two conditions we checked, we know this point is saddle point. So point A is saddle point. So this is the point A. At point B. The point B is x is 7, y is minus 3, x is negative 6 times to the 7, so it's negative 42. That y is 12 times negative 3 is equal to negative 36. So they are both smaller than 0. So zx times zy equal to negative 42 times negative 36 is greater than 0. And this one, zx times zy is greater than zxy to the power 2. Because zxy to the power 2 is 0, because this negative times negative is positive, so this will be positive 42 times 36 is greater than 0. So if these two conditions smaller 0, and this condition is greater than the zxy to the power 2, so if these two conditions checked, we will know this point is the maximum. So B is maximum. If you want to check the point C and point D, you can use the similar method to do that. For this question, we do the part A, find the critical point, and for the part B, we test the function, so it's the maximum. So this is the answer for the question.